So hello students, this is setup for thermal conductivity of insulating powder. So first we will see what are the various accessory attached with this complete setup. So here you are seeing this red dome. Okay, that red dome, that is nothing but your spherical, outer spherical zone and inner spherical zone. Okay, so in our calculation part and in our theory part we will understand how this spherical zone will be there. So how the cross sectional part of this spherical zone will be there. So outer sphere has 6 thermocouple. So you can see this is your outer sphere. So in this outer sphere it has total 6 thermocouple. Okay, and inner sphere it has 6 thermocouple. At the center of this sphere we have one coil where we have to arrange voltage and current. So here you can see 60 voltage I have arranged. Okay, and through this 60 voltage current is flowing 1.247 ampere. Okay, ammeter and voltmeter is connected to the heater coil. So heater coil will gain energy through this voltage. Okay, so at every 10-minute interval of time we have to calculate, we have to observe the different temperature. So 6 thermocouple is at inner sphere, okay, and 6 thermocouple is at outer sphere. So you can see these are our T1, T2, T3, T4, T5, T6, 6 thermocouple. This is arranged at our inner sphere, and T7, T8, T9, T8, T9, T10, T11, T12, these are 6 thermocouple at outer sphere. So first at 0 time first reading you have to take. So how you have to take this first reading? You have to arrange this thermocouple pin here in this way, and then you have to see the temperature in our temperature thermometer. Okay, so here temperature indicator will give you the reading, that is 59 degrees Celsius. Okay, so similarly you have to see this T2 temperature. Okay, so T2 temperature here at least 2 minutes required, okay, for stable reading. So 58 degrees Celsius. Then similarly T3, you have to arrange T3, and then T3 temperature. Similarly T4, T5, T6, T7, T8, T9, T10, 11 and 12. Finally you have to write all these in your copy, okay, observation table, and then after 10 minutes again you have to take reading. Okay, so that reading should be your consequently same reading. Okay, then only you will stop your reading. Okay, unless and until your reading will not be same of 2 consecutive time slot, you have to take the reading. Okay, so this is the way through which you can achieve steady state. Okay, so thank you very much. This is all about the setup. This is your temperature box. Okay, similarly this is your temperature indicator, digital temperature indicator, voltage ammeter. Okay, and this is spherical sphere. So about this spherical sphere we have discussed in our regular observation and theory part. So you can observe this spherical sphere in very detail in your regular observation and your regular theory part. Okay, thank you very much. Experiment number 1, determination of thermal conductivity of insulating powder. So we have seen the setup of insulating powder, thermal conductivity. So now we look over some theory part behind this experimentation. So first of all, what is conduction? We know already conduction is transfer of energy from more energetic particle of a substance to adjacent less energetic one as a result of interaction between particle. Conduction can take place in solid, liquid and gases, but moreover the conduction occurs in solid mainly, because of free electron motion available in free electrons available in solid, okay, metal. Now in solid, it is due to combination of vibration of molecules in a lattice and energy transport by free electron. So about Fourier law of heat conduction, which is basic law for heat conduction. So in Fourier law of heat conduction, Q it is equal to minus Ka dt by dx, where K it is thermal conductivity, A area of cross section, dt by dx it is temperature gradient, Q it is nothing but heat transfer. So heat is conducted in direction of decreasing temperature, so that's why we can see this negative sign is there, negative minus Ka dt by dx. So thermal conductivity of material, it is a measure of ability of material to conduct heat, and high value of thermal conductivity indicate that material is a good conductor, and low value indicate material is a poor conductor. Okay, generally for insulator we use this poor conductivity material. So mainly insulating material we use generally, it is asbestos powder, glass wool, rubber. These are the some insulating material. Here in our experimentation, asbestos we are using. Okay, so this material offer resistance to heat flow and are useful in saving energy also. This material possesses relatively small thermal conductivity because of absence of free electron. Now we have seen the experimental setup. So in this experimental setup, spherical dome we have seen, red color spherical dome. So in during your experimentation, I have told you that one it will be a inner radius and another it will be a outer radius. So you can see this is your inner radius, this is your inner radius, and this is your outer radius. So inner radius and outer radius. So in inner radius you can see T1, T2, T3, T4, T5 and T6. Similarly at outer radius you can see T7, T8, T9, T11, T10, T11 and T12. So in inner radius 6 thermocouple will be there and outer radius 6 thermocouple are there. So why? Because to get uniform temperature, because heat is propagating from center towards your radial direction. So because it will not flow uniformly because of some anisotropic nature, or we can say some directional losses, so that's why we have to get uniform reading. So to get uniform reading, what we do, we do averaging of the six temperature at inner and averaging of the 6 temperature at outer. Okay, so this is nothing but junction box we have seen, and this is nothing but your temperature indicator, digital temperature indicator, and then ammeter and voltmeter we have arranged here. So heater coil, it is at the center. Okay, then insulated powder, it is in between inner and outer sphere. This is nothing but your insulated powder. Okay, this is nothing but your insulated powder. Okay, so in this way this setup is there. So about next, this consists of two thin walled hollow aluminum sphere. So it is aluminum sphere. Inner sphere houses an electric heater, and then heater is made up of nichrome strip, okay, and wound on a mica core and embedded in mica sheet to insulate it electrically. The inner sphere is placed in the outer sphere concentrically. Okay, concentrically we have arranged here inner and outer sphere with single support. So the space between two spheres is filled with commercially available asbestos magnesium powder. So we filled commercially available asbestos magnesium powder. Okay, 6 copper constant thermocouples are taken out to junction box. So similarly, dimmer state to arrange your voltage. Okay, watt meter we have arranged here. So temperature across sphere. So temperature across sphere layer of insulating powder is measured by taking average of thermocouple reading indicated on the temperature indicator. Now for calculation, first we understand how this setup will be. So T1, T2, T3, T4, T5, T6, this are your T1, T2, T3, T4, then T5 and T6, these are your inner temperatures. Okay, then your outer temperature will be T7, T8, T9, T10, T11, T12. Okay, this is at outer. So we have to take the mean of inner and outer. Okay, so likewise we proceed here. So Q it is equal to minus Ka dt by dr, because in radial direction heat is propagating. So we integrate both side. So one for Q upon A dr, it will be R1 to R2. What is R1? It is inner radius of sphere, and R2 it is outer radius of sphere. And for K dt, temperature from inner temperature to outer temperature, that is Ti to T0, Ti to To, that is Ti it is average inner sphere temperature. So how I will calculate average? Average will be T1 plus T2 plus T3 plus T4 plus T5 plus T6 divided with 6, that is